Hi everyone, in this video I'd like to introduce how to extend the technique of the synthetic division when the divisor is not monic, but if you have this linear divisor, degree 1, with the coefficient in front of x, which is not 1. So first we're going to review the usual synthetic division process. So we use the synthetic division only when the divisor is linear, when that means the degree is 1, and we do that to rewrite this type of quotient. If you have a polynomial degree greater than or equal to 1, then if you divide it by this polynomial with a degree 1, you can write it as a polynomial part, and the part which called the rational part, whose numerator has a degree less than the denominator, which in this case, because the degree of the denominator is 1, in that case the numerator has to be a constant. Especially this synthetic division, sorry about the typo, is going to be very useful when we factor out the linear factor from a polynomial that is given in this form. So that's the main application of a synthetic division. So here's the first thing we do. We write the divisor, which is x minus 3, write it here, and notice that this is a monic. That means the coefficient of x here is 1. And what you write here is a 0 of this linear polynomial, this degree 1 polynomial. Namely, you set this one equal to 0 and write that number. Usually in this case, monic case, which is simply just the opposite sign of the constant part. When this is not monic, it is not that simple. You actually have to set that equal to 0 and solve for x. That is called a 0, which is written here. That's the first step in the synthetic division. Next step is writing the coefficient of a numerator, the dividend, in this order. 2 is the leading coefficient, and negative 7 is the coefficient of next highest term, degree 2. And here's a 0 because it's supposed to be something x to the first. If it is missing, you can interpret it as a 0 times x to the first, and 5 is a constant. So you write those coefficients in the order, descending order of the power. Then this process is supposed to be very similar to the long division process. Well, in the long division, we have this negative 3. We play with this negative 3, but here we switch that to 3. So in the long division, you always subtract the bottom row from the top row because we have already switched the sign. What happens here, you have to add those coefficients that is involved in this synthetic division. First thing is that you write down this 2 down here, and we multiply this 2 by this 0, 3. That if we put down something up there in the quotient when you do the long division, we multiply those by this coefficient. Because this has a few terms, just the 2 terms, we just have to play with this constant. That's why we're multiplying. I hope this is very familiar because I assume you knew the long division, so that's what this process is about. So you multiply. Rather than negative 3, we multiply actually positive 3. That's why we're supposed to add these 2 coefficients, not subtracting it, because you already took care of the switch the sign. So what you write down here is the sum of these 2 numbers, which is supposed to be negative 1. That's why you see it down here, negative 1. So next step is that you multiply this one by this 0, negative, positive 3 again. So you expect over there it's going to be negative 3. So if you multiply 3, you get negative 3 again. We're not subtracting in the synthetic division, we're adding these 2 numbers. So if you add these, you have negative 3. Then as the last step, you multiply 3 to that negative 3, so you expect that's negative 9. That's what you have, the negative 9, and then you add this 2 number to get negative 4 down there. So that's negative 4. So these numbers show up exactly if you do the long division with this whole thing, and you can find these 2 and negative 1 and negative 3 up there in the quotient spot, and you will find this number all the way down there at the bottom, negative 4. So you know that's the remainder, and these are the coefficients of the quotient. Since we're dividing this polynomial, whatever degree, by this degree 1 polynomial, quotient is supposed to be degree 1 degree less. So you're expecting this quotient is a degree 2 because the numerator is degree 3, knocked down by 1, so it's degree 2. So that's the coefficient of degree 2. coefficient of the degree 1, and that's the constant part. So that's coefficient of a quadratic polynomial. So I assume this is kind of review. I try to encourage you to compare this one with a long division so that you understand why this thing works like this. But the main purpose of this video is to extend this technique to the divisor that is not monic, but degree 1. So here's a kind of the summary. This is whole purpose, and then we went through the synthetic division. They're all numbers. There's no power attached to it. So this is a kind of, once you get used to it, then this is supposed to be a quick way of doing the long division. So that quotient part, this one, the 3 terms, if you start from here, constant, degree 1 and degree 2, that goes to the quotient part here, 2x squared minus x minus 3. Those are 2 appeared there as a coefficient of x squared, negative 1, coefficient of x, negative 3, constant inside the quotient, and x minus 3 were the divisor. And the remainder is written here. So out of that, doing the division, what you get is this important statement. The dividend, the degree 3 polynomial, can be broken up into this divisor times the quotient plus remainder. By dividing actually the both sides by this divisor, you can write this quotient into a polynomial part, which is a quotient part there, and remainder divided by divisor. So remainder has degree less than the divisor, so that's the form we can pull out. So that's what you get out of synthetic division. Let's extend this one for non-monic divisor of degree 1. So here's a typical problem. Here's a high degree polynomial. We're dividing that polynomial by a divisor of degree 1, but this time what's in front of x is 3, so it's not linear. So how are we going to do this with a synthetic division? Well, first we have to look at the long division and get the answer and compare with what we get out of the synthetic division. So here's what happens if you divide this degree 3 polynomial by this degree 1 polynomial using this long division process. So here's the quotient and here's the remainder, and that's what's going to happen. So I'm going to show you this again, but first you may pause the video for a while and do this long division yourself and understand what's going on here first. So I'm not going to do this with you, but I want you to do that. So here's the quotient we're about to do, and then this is the beginning of the synthetic division. It's very, very similar. Actually, the beginning is exactly the same as the usual synthetic division. You write down that divisor of degree 1, 3x plus 6, and you compute the 0 of this polynomial. That is neither negative 6 or positive 6. You have to set this one equal to 0 and solve for x. That's what the 0 is. So that negative 2 goes there. So we're going to play with this negative 2 and write down the coefficient of degree 3. And none of the terms missing here. So it's a 3 and 4 and 3 down there. You write this down. So let's do the usual synthetic division. So now you write down this 1. I'm noticing here the leading coefficient is not 1, so we do something different at the very end. So you write down 1, multiply negative 2. It's right up there. You add these two numbers. That's the difference between synthetic division and long division. We add this, the positive one. Now you multiply the 0 again, so that's a negative 2 here. You add this 2, we got a positive 2. You multiply to negative 4 if you add this to negative 1. So if this were just x plus 2, this will be a quotient and that will be a remainder, right? But one last thing, the additional thing you have to do when it is leading coefficient of divisor is not 1 is the following. Right, this is the perfect time to bring back the result from the long division. So if you actually divide that polynomial and your quotient is this all the number with the 3 in the denominator, so look at the numerator is 1, 1, 2, and the remainder is negative 1. So if you look at it here, the quotient does not have a 3 in the denominator, but it has 1, 1, 2, that number is in the numerator, and the remainder was the correct remainder, negative 1. So from the long division, the correct answer was 1/3, 1/3, and 2/3 in front of all these terms. But what you get from the synthetic division is 1, 1, 2. So we got this 1, 1, 2 in the numerator, but the denominator 3, 3 is additionally there. You look around where the 3 came from, that was exactly this leading coefficient. So the last step you have to do in the synthetic division is that you copy the remainder exactly there, but you divide all the coefficient of the quotient part by 3. Then it turns out it's a correct solution. So that is the end of the instruction of how to do the synthetic division when the divisor is not monic, the leading coefficient is not 1, but has degree 1. So the next part is going to be explanation. Why is this weird thing happens? It's only the quotient is divided by 3 and remainder stays the same. That's kind of odd. So let me explain what's really happening algebraically. So this is what's happening. You write down this quotient form, the numerator and the divisor, dividend and divisor, and we're going to turn this into a usual synthetic division situation by factoring out 3. Here I factor out 3, and sometimes this constant here is not the exact multiple of this leading coefficient. In that case, what you have to do is just divide this number by sorry about that, this is supposed to be 3, so that this is 2. So 6 divided by the number you're factoring out, so that it's going to be 2. Right? So you factor out, sometimes it's not divisible by 3, you can still factor out 3 and have this fractional expression. Again, this is a mistake, it's 6 divided by 3 is what it's supposed to be there. And then I'm going to just completely factor out so that what's remaining here is our usual synthetic division. So here it is, that 3 was there to multiply to the whole quantity x plus 2, now it's factored out outside the whole thing. So if you just look at this one, that's our usual synthetic division with a monic degree 1 polynomial down there. So this is exactly what we did actually. If you go back to the synthetic division process, the process is really exactly these things. Let me show you again. So here, that's the copy of the synthetic division we did, and we write down the 0. That's exactly the 0 that you saw in the denominator, and that's exactly the coefficient. So this part here is as if the divisor is just x plus 2. So here's x plus 2, and we didn't touch anything of this numerator, so that synthetic division is it's going to give you the result about this one. So I'm copying down here. So that synthetic division gives you 1, 1, 2 as a coefficient for the quotient and -1 as a remainder. So I copy down 1, 1, 2, that's the quotient part in this a rational form, quotient form. The quotient just appeared as a polynomial, and the remainder goes to numerator of this fractional part. That was -1, I pulled that out. So that's the result if the divisor is x plus 2. But this whole thing is supposed to be the answer. So what you have to do is that you distribute this 1/3 over this coefficient of the quotient part, and also you have to be multiplied there. And that part will explain what happened with the remainder. So here's what happened. Of course, this is multiplied through the quotient, so that's why all the coefficient of the quotient part is divided by 3. But when this one is multiplied to that part, you can only put that 3 in the numerator or the denominator. It's not going to distribute both numerator and denominator. So this was used to recover this denominator, the divisor, back to what it was, 3x plus 6. But there was no x plus 2 in the denominator or anything, so that's why the 3 is shown there. And again, 3 went back to the divisor to recover the original shape of the divisor and make it look like that. So that's why the remainder was untouched, but the coefficient was divided by 3. It also explains the whole method, the extended. Thanks.